All right, today I'm sitting down with Dr. Jessica Esquivel. Dr. Esquivel is a postdoctoral research associate at the Fermi National Accelerator Laboratory, working on the muon G2 experiment, and she's also a fellow Texan. Welcome, Dr. Esquivel. Thank you so much for sitting down with us today.
Thank you for having me. I'm super excited to be here. Sorry, my dog was messing with the curtains in the background, so.
No problem. Dogs are always welcome in these kind of talks. Do you remember when you first decided you wanted to become a scientist?
Yeah, I was really young when I realized that STEM was interesting to me. So STEM is science, technology, engineering, and mathematics. Coming from a single family household, I spent a lot of time with my aunt, and we used to watch sci-fi shows and movies all the time. And in one of those shows, there was an astronaut in space fighting aliens, and a NASA scientist down on the ground essentially telling the astronaut what to do and what buttons to press and how to save, the galaxy. And it was at that time, I think I was 5 or 6 years old, where I started walking around saying I was going to be an astrophysicist. So obviously I didn't have knowledge of what that actually meant, but I knew that it was really interesting. And my family kind of propelled me into that interest. They took me to NASA. They showed me, what astrophysicists did. And I was actually not as impressed as watching the TV, the movie and the TV shows. But there was still an interest there. And because my family kept propelling me into science and mathematics, it really developed into a passion. And it all started with just that TV show, though. So
what the TV show was?
I don't remember. I was too young. But the Sci-Fi Channel always has, silly silly little shows like that. I can't remember specifically off the top of my head what it was.
So it seems like your family in general was pretty supportive.
Yes, definitely.
Did you receive any pushback, or was it all support when you were telling people that you wanted to be a scientist?
It was support from the get-go. My mom used to have a little tablet of professions that she wanted her daughters to go into. Most of my family are nurses or nurse practitioners or in the medical field. And I remember one time my mom got a splinter in her finger, and she told me to go get the tweezers so I could take it out. And at that point, my hands are clammy and I was feeling nauseous, just digging in to get a splinter. So there was a lot of those, instances where my mom was like, yep, she's not going to be a nurse. But essentially with all of the, crossing off, that math and science always was at the top. There was pushback when I told her that I wanted to go to graduate school. That wasn't something that was nomenclature in our family. We didn't know what graduate school meant. When I told her that they would pay for me to go to school, she didn't believe that. She didn't want me to be a perpetual student, So there was a little bit of pushback there, but it was lack of knowledge within our family that was coming from. And once I told her that there were resources and explained, that yes, you can get a job as a physicist, she was right on board. And during the complications I had, and obstacles that I faced in grad school, she was right there next to me, pushing me. So
now you work for Fermilab. For someone who's not familiar with your field, would you be able to describe a little bit about the work that Fermilab does?
Yeah, of course. So Fermilab is shorthand for Fermi National Accelerator Laboratory. We are funded by the Department of Energy. We're a national lab, and we study the building blocks of the universe with the biggest detectors in the country. So that's our tagline. But essentially what we do as physicists is ask really big questions that are at the bleeding edge of our knowledge. So we study things really, really large, ask questions about the beginnings of the universe, how we came to be, what's going on in our galaxy and in our cosmos. And we also ask questions about the really, really small, and that's where I come in, with regards to what's smaller than a proton and a neutron. How are protons and neutrons created? What is an electron, and how do they interact with other things around us? And then even smaller and smaller things like neutrinos, which are pesky, ghostly particles that travel through us millions and millions undetected. They're just really, really interesting, pesky particles. So we go really, really big and really, really small. But the questions that we ask are to push society's knowledge forward.
I was reading from your profile that you're working on something called the muon G2 experiment. First of all, what is a muon? And also, why is this important? This question important for your field?
Yeah. So a muon is like an electron. I call it the plus size sibling because it's heavier. It has a lot of the same properties as an electron. It spins in a magnetic field, just like an electron. But because it's heavier, we can use it as a telescope into the unknown. And that's essentially what the muon G-2 experiment is doing. So the G-2 is actually an equation. What G is we call it the G factor, but it's the spinning that muon does in a magnetic field. So as a particle physicist, what I'm looking at is how the muon's choreography going around a big magnet or a magnetic field changes as it's spinning around. So it's spinning this way, but then it's also spinning in a circle in our big old magnet. So the magnet's 50 foot in diameter, so it's a big thing, and it's a very, very uniform magnetic field because we want to keep that the same throughout, because something super sci-fi happens. Virtual particles actually pop in and out of existence. There's this thing called the quantum foam, where when you zoom really, really far into empty space, it really isn't empty. There's these boiling, bubbling particles that are kind of just popping in and out of existence, spontaneously. And for the most part, we as particle physicists know which ones pop in and how they change the muon's choreography. But by making a very, very precise measurement, we can peek in to see if a new particle pops into existence and changes the choreography of that muon in an unprecedented or unexpected way. So that's what we're looking for. And there's hints that this is actually true. The experiment that I'm on was done in the 80s, 90s, and they saw a veering from theory. So what we measured was different than what we theorized. And that's pointing towards new physics. So we're making this measurement way more precise so we can be sure that we just saw something new.
It's fascinating.
It really is. And I mean, when I talk about it, it's still like, yeah, this is stuff that could be in movies, man. Like, people are not going to believe that this is what I'm studying, but it's just so fascinating that that's literally what I'm studying. So, yeah.
Have you encountered any setbacks in your career? And if so, how have you overcome those setbacks?
Yeah, I mean, particle physics as a whole is pretty homogeneously white and male. These spaces weren't built for people that look like me. And even when I tell somebody that I have a PhD in particle physics, I get no way, or how? You don't look like a physicist. So those types of microaggressions and disbelief in the fact that I can do this work is just compounded on top of the fact that this work is already hard to begin with. Like, nobody goes into physics thinking it's going to be a breeze. We all know that it's going to be difficult. We know that the qualifying exam tests all of the knowledge you've ever encountered in your physics journey, and you have to pass it to do the fun stuff, which is the research and the answering of the hard questions. So we go in knowing that this is already going to be hard. But the fact that the space is overwhelmingly white and overwhelmingly male, and the fact that I have to advocate that I belong there and that science is for everyone, and that these amazing, awesome, interesting, mind-blowing questions should be able to be asked and answered by people that look like me, that was and still is a struggle.
I had been reading on your profile that you are only one of 150 Black women in the United States with a PhD in physics, which is an astonishingly low number.
Yep.
How can science institutions and other places encourage more diversity in physics?
I think we need to stop thinking about diversity and inclusion as a commodity or as lip service. We need to be sitting down and actually drafting up action plans and resolutions that not only address the lack of representation in the field, but also address the systemic oppression that we're seeing in society as a whole, but also we are a microcosm of society, so in our specific field as well. So I always come back to what I call the 3 R's, which is retention, representation, and recruitment. And if we focus on only one of those, you're not going to see the change that you want, right? You need to be focusing on all 3 of those in parallel. And what that looks like is, you know, putting somebody that looks like me with a platform to talk about the physics, not only just the struggles that we're going through, but the physics, which is what we're really interested in, and putting out diverse representations of what a physicist looks like, right? Retention goes back to changing the system and changing the organizations that we work with and changing the climate so somebody like me feels accepted and can thrive, not just survive, thrive in these fields, right? And then we have recruitment, and that is, you know, directly battling that quote unquote pipeline problem that we have. So when we're looking to hire diverse representation in our field, we have a cohort of scientists that are ready and willing and able to do, you know, this amazing work. So, yeah.
And lastly, what advice do you have for young people that are interested in pursuing physics or just a STEM career in general?
I always say just be stubborn. I mean, they're gonna try and push you out. They're gonna try and say that you don't belong, that you're not smart enough, that you're not good enough, and it's all noise. It's just all noise. And I know it's hard to try and tune it out, but to the best of your ability, do that. And I've seen a lot of people on social media say that your existence is your resistance. And for right now in these times, that really is like so powerful to hear, that you belong in that space and that you should exist happy, you know, to do this physics and to be in these spaces.
Thank you so much for joining us. If there's anyone who wants to follow up and keep up with you and your work, is there a place they can follow you?
Yeah, I'm pretty active on Twitter. It's Dr. Esquivel, PhD, and actually that's on pretty much all platforms. You can find me on that, but I'm most active on Twitter.
Thank you so much, Dr. Esquivel. Everybody follow her on Twitter. Thank you so much. I really appreciate you sitting down with us today.